Hi, my name is Isra Anantawarasin. Welcome to Computer Network and the Internet course. The course is part of a financial engineering program which is offered by KMDL and LIDA. During the course, as the name suggests, we will discuss how computer network and the internet works. All right, and we will also discuss more advanced topics like network security and a little bit of cryptography as well. The course will be divided into two parts, the video part and the on-site part. The video part will cover lecture 1 to lecture 6 from July the 3rd to August the 11th. All right. And the on-site part will cover the rest from lecture 7 to lecture 15. I will explain later during the video. All right. So without further ado, let's dive into the lecture. So first, let's start with the course description. This course provides an overview of computer networks and the communications and the internet, covering following topics: computer network reference model, right, such as OC and TCP/IP, basics of wireless and wireless network, all right, digital communication, concept of peer-to-peer communication, standards like protocols, routing, quality of service or QoS, and standard examples of transport protocols such as the TCP and UDP protocol, all right, network security, computer network application services, all right, like email, World Wide Web, voice and video communication over the networks, all right. So it sounds long and boring. So let me get you the short description. You will learn how the internet works, okay. You will also learn how to survive it. Okay, so basically what I mean by surviving is that you need to know how to protect yourself, you need to know how to protect your data, all right. And yeah, so let's discuss first what is the internet. All right, well, we are using internet every day. All right, we are using it right now. When you watch my video right now online, all right, you are basically using the internet. So what is the internet? All right, it is the website or World Wide Web. Is it email? All right, maybe video conferences, maybe line call, right? Or other games. Well, yes, you can also play games online, right? You can play it offline, you can play it alone, but well, right now things are going online. Everything is online. But what is online? What is the internet? All right. So before we discuss that, what are these things that we are showing here on this screen? Website, email, video conferences, games. These are the services on the internet. All right. They are not the internet. They are something you could do on the internet, something you could do online. All right. So let's have a look at the Facebook page that I'm showing you right now. Where is Facebook.com? All right. You are using it every day. I don't know what you guys are using. You can use the TikTok, YouTube, whatever social media you're using. But do you know where is the data? All right. Here's the thing. Nobody cares at all. Nobody cares where the data are. Nobody cares where these websites are. Nobody cares what's going on, what happened after I post something online, where would the data going to be stored, or where the data gonna will come from. All right, they just make sure that once I tap on this button, something happened. When I tapped on the video, it's supposed to play. All right, so but that's nothing wrong with that. There's nothing wrong with that. The internet is designed in such a way that the users do not have to understand about anything. Well, not in the early versions, but right now, all right. A lot of people are using the internet, so we know that, and a lot of people they are not technical people, all right. So their background on the matter is, of course, very limited. Therefore, it is designed to be easy to use, all right, And I think it's also easy to understand, but yeah, that's what we are going to figure out during this course. Okay, so the data, once you post it online, all right, what it where does it go? Your messages, your picture, they're going on the cloud, going to go into the cloud, all right. And the cloud, the word cloud is not new. The word cloud has the concept of cloud, not the word. The concept of cloud has been there since the beginning of the internet. All right. If you see, if you have a look at the network, computer network textbook, you're gonna see a lot of this cloud symbol right here that symbolize the internet. All right. That denotes the internet. So as I was saying, it is designed to be, well, cloud that you don't have to understand, you don't have to know about where the server is, where your data is going to go to. All right, what you want to make sure is that the URL that you type in is the correct one, so you landed onto the correct website. Okay, so what is the internet actually? All right, the internet come from two words: inter networking. Sometimes some people call it network of networks. All right. So if you lift up the cloud, you will see these little, well, clouds, all right, smaller clouds. And as you can see here, Facebook.com could reside in one of these small clouds, all right, one network. And then you are residing in another cloud, in a small network. It could be your apartment network, your home network, or your university network. All right, but you are connecting to something. All right, in cafe, in Starbucks. All right, in your dorm, whatever. And that means that you are connecting to your own network. But when these networks are connected to each other, they can somehow pass along the information from facebook.com to a web browser. And if you post something online, all right, either it's going to be picture, instant messages, these messages will go through your network, through other networks until it reaches the destination. And to understand how it works, how these networks work, all right, well, that's the handful of words. Okay, so how do you even understand how this network works? We need to go back to the source. We need to go back, well, several hundred years or maybe 1,000 years. Okay, so in the former times, all right, when, well, human building their civilizations, we're gonna have like big cities, small cities. You have big towns, small towns. These towns are mostly separated. Okay, but in each town you have houses, you have buildings, you have temples. These structures are connected by the road inside this town. Okay, but then when they want to communicate to each other, these towns can also be connected by roads too. Okay, and to navigate through these towns, all right, for example, if you want to go from A to B, okay, what you need to know, what you need to have is the perfect road system. You need to know the address of the place or the location where you need to go. For example, you want to go from here to here. Okay, hold on. All right. If you wanna, now you know what? Let me put the let me use another example. If you want to send message, okay, from your place here to your friend's place here in the other town, okay, what you need to know is you need to know your friend's name and address, okay, so that the delivery service, whatever they're using back in the day, they can just, send the message to the right place. And of course, you're gonna need your friend's name to identify who is the actual recipient, because this could be a hotel, this could be a castle, this could be a house, but most certainly there are going to be a lot of people living in the same place, right? That you need to know who this message belong to, all right? And if you want your friend to reply back to you, you also need to specify your name as well. So therefore, you're going to need your name and your address. You need to put that into the letter or the envelope so that the recipient can reply back to you. And the recipient going to know, oh, okay, this message is from you and you're living in this house at A. Okay? So just to be clear, well, in order to make sure that the message arrive at the right place, okay, to the right guy, you need a clear and precise house numbers and road networks, okay? And for example, you shouldn't have two towns that have the same name, okay? Well, that happens in some countries, but it is quite rare. But at least if you have the same, maybe the same road name, okay, for example, Sukhumvit Road, okay, that runs to from Bangkok to Trat, okay, all the cities along the way have some place that reside on Sukhumvit Road, but you know that okay, this number on the Sukhumvit Road in this city is not the same house with the same address on the Sukhumvit Road on the other city, okay. So you need a clear house number or house addressing system. Apart from the addressing itself, okay, you want to make sure that the delivery service is reliable. Okay, you don't want to send a letter or packages or using a service that always lose their packages or that always damage the packages. All right, you want to make sure that your packages or your letter reach the destination safely and correctly. All right. So let's have a look at this example. This is the postcard that my friend, all right, is the recipient, Nai Kumrit here. I don't know who sent this to him, all right. But anyway, take a look at this. I'm sure that you are familiar with the format and the system, but let me recap real quick. Here we have the postal number or zip code in the immigrant system. And here we have the city, okay, we have Amher, okay, and then we have Tambon right here, district or sub-district, and then we have the road, okay, and we have the house number. This is the address. And then once the postman send this letter to this address, his job is basically done. Okay? But it's up to the people in the house in this address to deliver this particular letter to Naikomrit right here. It could be his mom, his wife, his friends, his daughter, his sister that deliver, or himself that delivered the letter to Komrit. Okay? But the job of the postman or the postal system as a whole is done once this letter is dropped at this address. Okay? Now, so we have two parts, the recipient, okay, right here, and the address of the recipient right here. And this part, the entire thing, is the information of the receiver of this letter. But how about the sender? Okay? The sender part is usually on the top left corner of a mail or a postcard, all right? But the format is the same, even though a little bit smaller, but the format is the same. Right here, you have the name of the sender and the address. I mean, right here too, address of the sender. Okay? And it works globally. So if you send this letter to somewhere in the US, for example, you need to specify the country, which is the USA. All right, you need to specify a little bit more. Maybe apart from zip code, you're gonna need to specify the state, okay, and the city or town where your friend lives, and then the road, and then come back to the house number, all right? And of course, don't forget your friend's name, the recipient's name. Well, but all in all, it works globally. What it means is that if this address, okay, if this letter specify for some address in the US, what the postman is gonna do, or the post office is gonna do, is that it is going to send this to the airport somewhere and then put that onto a plane, and that plane gonna land in the destination country, and that country is gonna sort this address out by themselves. Okay. So now let's just have to look as a picture. Okay, how does it work? For example, you send your letter in a post box near your place, right? And then once the letter are collected by the post office, your local post office, it is going to sort it out, okay, where this letter is supposed to be, where this letter is supposed to be sent to, and then put that into a truck, okay, in the that has a destination near your friend's place or recipient place. And then once it reaches the destination office is going to sort the address out and so on, and then maybe forward the address further into some smaller offices, or maybe and maybe send the letter, or assign the letter to a postman, and then the postman is going to send the letter to the destinations or your friend's place. Okay, but again, as I was saying, this works globally. So it could be not just local post office, but it could be international post office or destination post office in other countries and so on. All right. So come back to present day. The technology that we discussed earlier, which is the postal service, well, it has been there since the beginning of towns, I think. All right, somehow people want to communicate, even though it takes longer, more expensive. All right, and maybe a lot harder to deliver messages from one place to another place. But that was before the internet. So if you talk about present day, the main functionality of networking is to deliver digital messages from host A to host B. The host A and host B refer to computer A to computer B. Okay, that again refer to an iPhone, iPad, laptop, whatever. All right, some digital devices. Okay, some devices to another devices. Right. So, as I told you earlier, the internet come from two words, right? Inter-networking, or network of networks. So cities, town, districts, sub-districts are sub-networks of the internet right here. You have smaller networks, and then these networks are connecting to each other. Okay, houses, buildings, computer, mobile devices are hosts. Okay, so it works like this. You have these smaller towns or smaller subnetworks, like so. And inside you have your devices. Okay, we call it a host. All right, and these devices could be anything. Could be a phone, could be computers, whatnot. All right, but that's not all. That's not all. We are talking about programs inside each of these hosts. All right, these programs that send data to the internet or receive data from the internet. Okay, we call these program applications together processes. Okay, well, we call it processes because the term is more generic, and also some program or some app could send many data to many recipients at the same time, or receive data from many senders at the same time. And sometimes each these program like a web browser, Okay, they could have smaller sub-processes. Therefore, process is the better description of sender and the recipient of digital messages. All right. So before we go on, let us introduce some technical jargons or technical terminologies real quick. All right. The network of networks that we use today, well, the internet, are connected together using what we call the TCP/IP protocol suite. Okay, there are, well, right now you don't have to understand anything about this. It is just that what it means is that um, the all the networks, all the sub networks on the internet, okay, they talk the same language, and that language being TCP and IP. Okay, millions of the devices are connected, ranging from mainframe computers, supercomputers, high performance computers, personal computers, well, mobile phones, tablets, laptops, cars, whatnot. Everything is connected to the internet right now, and even my aircon that I'm using right now, it connects to the internet too. Okay, even a toaster. No, I didn't. I kid you not. This toaster can download picture over the internet and then toast it on a toast. Okay, all in all these devices that are connected to a network, we call them hosts. Okay, Um, sometimes you can also call them end systems. Okay, we call it end systems because this is the system at the end of the communication. One end system talk to another end system. All right. All right. Just to recap, in the real world, when you want to send a letter to your friend, you need to know his name right here. Okay, and you need to know his address to specify where he lives or where he works. Okay, now, and then you need this pattern. It should be enough, but it's not quite. So you need to, when you write a letter, you need to specify your name as well, and then your address as well, in case your friends want to reply back to you and want to know who sent him the letter. Okay, once you have these two pairs of information, the recipient name, location, and the sender name and location, you can call delivery service to deliver the letter to your friend. Okay, but the delivery service that you use, you want to make sure that he is reliable. What I mean by reliable is that first he know the address. He doesn't drop the message or the letter into the wrong place, and he knows the way how can he navigate himself to the right location. All right, that's the first thing. Know the address. The second thing is that he deliver the letter in a way that it is intact, it is not damaged, okay, and he doesn't change the content of the letter along the way. That comes later when we talk about network security. But right now, we just want to make sure that you send the letter intact correctly to the right place. And then once the letter arrives at the right place, all right, the system inside this house could be your friend, could be his mom, his wife, gonna sort this letter out and then send this letter to the right guy, which is your friend right here. Okay, well, that is the outside world. Let's just talk something digital. In the digital world, okay, in computer networks, the things work quite similar to the actual delivery service. Well, if this process wants to send some information to this process right here in another host, this process that resides in this host must know this host address. Okay, and in TCP/IP protocol on the internet, this the address of this guy. Sorry, I just added a here. The address of the recipient is specified by what we call the IP address. Okay, because we use IP protocol. And okay, the the receiving process inside this host is specified by what we call a transport port. You don't have to know what it is right now, but just for the sake of conversation, transport port is a temporary number that the operating system on this host assign to each process. It is not quite correct technically, but all right. But just to simplify our conversation right now. Now you have the address to specify the location of the host, and you have the port to specify the process that should receive the data. When you send the data, okay, over the internet, you need to also specify your host address as well. All right. You need to specify the sender, the IP address of the sender, and you need to specify the transport port of the sender to specify that, okay, I am the process that send this data. In case this process want to send some reply, some data back to this guy, he has to specify the same thing, IP address and the transport port as well. But in this direction, his role changed from the receiver to the sender, and his role changed from the sender to the receiver. Okay, but all in all, using this pair and this pair of addresses and ports is enough to send two-way communication between two hosts or two machines. All right, and this is the basic idea how data are being exchanged over the internet. You're going to use IP address and you're going to use transport port. Okay, and all this information, all this data that are transferred using the TCP IP protocol suite. All right. Well, we call it TCP IP, but let me tell you right now that this TCP IP protocol suite consists of some other protocol as well, but these two are the most important ones, and that's why they name the entire thing TCP and IP. Okay. Now that we discussed briefly how the internet works in the most basic idea, let's just discuss a little bit deeper. All right. Well, we discussed earlier that email, video conferences, World Wide Web, online games, the are services on the internet. All right. What are the services? The services are the software functionalities that are available on the internet. Okay. Well, what do we mean by that? See, if you talk about email, okay, it is a service that I can send messages from me to the other guy. All right. And then how do I send? I need to have his email address, something at something dot com dot org and so on. All right. But I want you to take a look at this. When we talk about email, you can use any applications you like. Okay, you can use Gmail, you can use Hotmail, you can use an offline email agent like Thunderbird, okay, or Outlook on Windows, or Mail on the Mac. All right. See, these applications are software that implement or use internet services. Another example is web browsers. You can use Firefox, you can use Edge, you can use Chrome, you can use Opera. All these applications are doing pretty much the same thing, visiting websites. Okay, so the World Wide Web is the service. The applications, Edge, Chrome, Internet Explorer, Safari, these are the applications that implement or use these services. Okay, but how do they work together? The software or the application that come from different backgrounds, come from different companies, come from different developers, yet they could talk to each other. All right, they could talk to each other because they are using the same network protocol. Okay, network protocol is the set of rules or set of commands, all right, that specify how the communication should behave, who should send some, how a process send data to that process, how the process should respond to the first process, and how the data should be format, how the data should be compressed. Okay, what are the commands and the steps of these commands? All right, we're going to discuss a little bit more in the next few slides. Okay, but this is the idea of the network protocol. But before we discuss the protocol, our network protocol, let's just discuss the human protocol first. Okay, consider the following scenario where Alice wants to ask Bob for the time. Okay, Alice, well, she is polite, so she greets Bob first. Hi. Then Bob replies, hi. Alice asks, what is the time now? Bob replies, 10. All right, I just say 10 in the 24-hour format. Okay, so Alice can communicate with Bob only when Bob understands English. Okay, and then knows how to reply. What does it mean? It means that if Alice asks something in French or in German, in Japanese, and Bob doesn't understand, Bob, Bob, even though he wants to help, he wouldn't understand what Alex is asking. Okay, and then once Bob understands the question, Bob must understand how to respond. Okay, he has to know the time and he has to use the right format, 10 o'clock. But if Bob replies in German, es ist 10 Uhr, something like this, or in Thai, 10 โมง. Okay, Alice might not be able to understand that as well. So both sides, the request, okay, the service requester and the service provider must understand each other and know how to respond to each other request or command. Okay. Well, if and even worse, if Alice say hi and Bob say go away or just ignore, then that communication wouldn't even establish in the first place. Okay, and this is human protocol. We need grammar, we need vocabulary, and we also need this etiquette, okay, or politeness, so that our social would function. Okay, what in network protocol they don't care much about the socializing. They just care about getting the job done. Okay, but how it works is quite similar in network protocol, similar to human protocol. The protocol rules are the protocols are the rules that define how to exchange information and how to react on the information or react on the request. Okay. Precisely, network protocol defines the format of the messages, either the request or the response, the order of the messages that are exchanged between two communication parties or two processes. Okay, the actions taken on the received message. What it means is that I got this request, I got this command, I got this text. What should I do with that? Okay, and a little bit more importantly, most protocols also specify how can the other one respond and responds to the response. For example, if if Alice asks Bob what's the time, and Bob say 10, okay, that's it. Well, in that particular scenario, Bob doesn't have to care that Alice get the message correctly. Can she hear that he says 10 or maybe he thought it is like 9 or whatever? Okay. Well, most of the time human doesn't have to really care whether the other guys understand me correctly or not. And sometimes that causes a lot of problems. But in network protocols, all right, most of the protocol also specify how can you make sure that the other side know that you understand the information. For example, if Alice asks Bob what's the time, Bob says 10, then if Alice is a network process, then Alice should reply to Bob, okay, succeed, or something to make sure that to inform or to ensure Bob's that, hey, I got your response, I got your time. The most important protocols on the internet, as we mentioned earlier, is the TCP protocol and the IP protocol. TCP stands for Transmission Control Protocol, and the IP stands for the Internet Protocol. What TCP does is that it dictates how the data should be sent effectively, correctly, and in order to the recipient. Okay, what I mean by effectively is that it is fast, but not too fast, so that it congests the network or the receiver cannot process the data fast enough. Okay, correctly and in order means that all the messages that are being transferred from host A to host B will arrive as host B in order. So message 1 come before message 2, message 2 before message 3, and so on. And then all the messages that are arriving at B are correct. There is no corruption during the transmission. The message are always error free. Okay, and we will discuss later when we discuss TCP protocol how this data correction works. IP protocols specify the format of the packets that are being sent and received along the network. All right. It is also responsible for host routing and addressing as well. What I mean by addressing, the host addressing means that um, each host on the internet, on the entire network, must have the address, and that address, okay, somehow specify who it is. Okay, there are no two addresses there are no two hosts that have the same address. Okay, and so on and so forth. The format of the address, and then well, how can we make sure that each of the hosts had different addresses, and that works globally. We're going to talk about that later during the course. And another type of IP is routing. Okay, routing is the process where you deliver the packet, okay, or the message to the correct address. No matter where this address is in the world, IP protocol is designed to push this message to the correct direction, correct country, correct cities, correct district, sub-district, until it arrive at the correct address. And we will learn later that IP address that we have, each computer that we use right now, had at least one IP address if it is connected to the internet, but it is not as simple as it look. Okay, but we will get back to this protocol soon. You might also be familiar with the term HTTP, HTTPS, SSL, the Ethernet, and so on. All right. Are these protocols? Well, in short, yeah, they are, but it is a little bit more than that. These protocols that you see right here, they are standard protocol. All right, I would call it an open protocol. You can write your own web server, you can write your own web browser that understand HTTP, and it would work in any website you like. All right, SSL, it is the encryption protocol. Okay, you can use that to encrypt HTTP, for example. You can encrypt data, you can encrypt email, you can encrypt line messages or video call, whatever. You can use it anyhow you like. It is open standard. Okay, and the Ethernet is a protocol that is designed to transfer data via LAN cable. Okay, but well, just to be sure that you are not confusing, have a look at this. We have Facebook Messenger. In Facebook Messenger, you can also make video calls. All right, you have Cisco WebEx, you have Google Hangout, Google Meet. I'm sorry, Hangout is the old name. Google Meet and Microsoft Teams. You have World Wide Web. Okay, and then you have this web browser, Firefox, Chrome, Edge, Safari. We have a lot of instant messaging services as well: Line, WhatsApp, Facebook. Okay, and just plain old messages. You can also have file sharing, and that they are using, these are the BitTorrent clients. All right. See, these services, okay, these services may be using different protocols. Okay, what do I mean by that? See, these video conference services, they are doing the same thing. They are basically doing video calls. Okay, it could be one-to-one call, one-to-many calls, many-to-many call. It doesn't matter. Okay, but they're doing the same thing, the same kind of service. All right, yet they are using different protocols. Microsoft Teams use proprietary protocol. Google Meet use proprietary protocol, and WebEx and Facebook as well. Instant messaging, same story. Line, WhatsApp, Facebook, and iMessage on the iPhone. All right, they are doing the same thing, instant messaging, but they are using their own protocol. Line has their own protocol, their own languages, their own language. WhatsApp has their own language. Facebook has their own language. Apple has its own language, and they cannot talk to each other. These video conferences as well, they cannot talk to each other because each of these company maybe maybe they implement their own set of commands or own set of messages, own set of languages. All right. Sadly, they are doing the same thing, competing to each other with each other, and they cannot talk to each other. On the other hand, if we talk about on this right hand side, these two services, they're using open protocol, World Wide Web, okay, or HTTP and HTTPS protocol is an open protocol. That means that you can have different web server, Nginx, Apache. You can have different web browsers, Firefox, Chrome, and so on, and they can work with each other because they are talking the language that they all understand, which is HTTP. Okay, in file sharing case as well, these clients, all right, they're using the same protocol, BitTorrent or torrent protocol. All right, some services may be provided by different applications. We just discussed that already. See, instant messaging, the same service, same kind of service, this is offered by the different applications and maybe different protocol as well. The last point here is that some applications may also provide many services. For example, okay, you can use Line to do instant messaging and also video conference. All right, it goes with pretty much everything. All right, FaceTime, Facebook, all right, and WhatsApp. These protocol, these applications, they are doing a lot of things. Okay, and sometimes they're using different protocols as well. In order to use the internet services, you need to first go online, right? Well, we call it casually going online. But what does it mean? All right. Going online is actually an activity where the end users use the end systems to connect to the internet to an access network. So basically, it's, for example, you and me, all right, use our iPhone to connect, well, to the internet via Wi-Fi, all right, or maybe using our laptop to connect to the internet using LAN cable, all right. The access network, all right, is a network that we are using to connect to the internet. All right, it could be your home router or home Wi-Fi. It could be LAN cable that connect to your home router. All right, the access network consists of the edge router. Okay, the very first router on the path from your machine on your VM system to another end system, from your machine to the internet, then further through facebook.com server, for instance. And the access link, which is the physical link that connects the end system to the edge router, for example, Wi-Fi or LAN cable. All right. We collectively call the entire set of devices, all right, set of end system at the end of the network. the network edge. All right. So let me show you the picture so that we can understand a little bit better. Here, this is our machines. All right. This is our machines, which could be our PC or laptop, Mac, iPhone, iPad. All right. And this is the first router. This is your edge router, which could be your the Wi-Fi router at home or at your dormitory, or it could be the Wi-Fi router in the classroom. All right. So we have the end user, which is you. Okay, using the end system, which is your machine. All right, connecting to your edge router, and the signal, the Wi-Fi signal or the LAN cable that connects to your machine with the router is the access link. Your first router here will further connect it to the next router and the next router and the next router and the next router until it reaches your destination. Okay. For example, if you are connecting if you're connecting to the internet using the Wi-Fi router in the university, you have for example, your laptop here, okay, connected to your classroom router. The classroom router connects to the building router, and the building router connects to KMTL gateway router. All right, and it further connect to the ISP, and then further to the ISP, a larger ISP, until it reaches the destination. To summarize, the end system are components at the end of the networks. Okay, the access link and the edge router are highlighted here in red. Okay, it could be your machines here. Okay, and or machines here, or it could be the server at the end of the other end of the communication. It could be Facebook server or Hotmail whatsoever. Okay. The communication through the network is about communicating between the end systems. See, the routers or any network components along the way, you normally don't connect to them unless you are the network administrator. When we talk about connecting, okay, when we talk about exchanging messages, we're talking about the end system to end system only, from your machine to your friend's machine, okay, from your machine, from your iPhone to your friend's iPhone, so that you can do video conference, okay, or from your machine to a Hotmail or Gmail server to access your email. Okay, so when we generally talk about communication, what we mean is the end to end, okay, between end system to end system communication. So let's have a look at the technologies that we can use to access the internet, okay, or the access link technologies. First, we have the telephone line. All right, we can use the DSL protocol or dial-up protocol to connect to the internet or to go online using our classical telephone network. All right. Another one, okay, that you might be familiar with is the Ethernet protocol or LAN cable. All right, sometimes we call it LAN protocol. For the sake of simplicity, you are familiar with with such cables already, I guess. And if you are living in the remote area, you might be interested in the satellite technology. Okay, this satellite right here is a Starlink satellite. All right, Starlink is the internet providing service by Elon Musk. Starlink allow you to connect to the internet anywhere on Earth using this small satellite dish only. All right, pretty amazing. The next one is the terrestrial radio. So Wi-Fi, WiMAX, GPS, or 2G, 3G, UMTS, okay, or 4G or 5G. Basically, your mobile phone. You're using cellular network. All right. You can use the fiber optics to connect to the internet. Okay, usually fiber optics doesn't connect to your machine directly. It connects through the router. So if you want to have fiber optic service, you need to have this fiber optic router installed in your place, in your home, or in your office. Okay. Similarly, you can also connect to the internet using the coaxial cable or the TV cable. All right, coaxial cable It is a thick cable. All right. If you're familiar with the TV cable, it is basically the same technology. You have the shielding outside. Okay. You have the core copper inside, and you have another the copper wiring right here. Okay. And between this core and the one right here, you have this insulation. Okay, in between. To make sure we are on the same page, let's consider this scenario. Okay, your friends want to surf the internet to do video call with her friends, all right, online. She already has a laptop with a webcam, but she needs an internet access at home. More than that, she also wants to make sure she also wants to connect to the internet anywhere in the house. Okay, um, she knows that you are studying computer. Therefore, she calls you for help. And sure enough, you can help her. Okay. So you figure that the best internet access, which is the most suitable for your friend, is fiber optics. Okay. So you call up the internet ISP or internet service provider and subscribe for fiber optic service. It could be True, Tree Broadband, TOT, AS Fiber, doesn't matter. Okay. So a week later, the fiber optic service is installed on your friend's house. The technician wires a fiber cable into your friend's house. But that's not it. Okay, that's the beginning of the installation. Next step, you need to get a wireless router or wireless modem router. Okay, so you go buy the router, and then at the home, you plug in the fiber optic cable to the router that you just bought. And then you set up the router, set up the Wi-Fi, set up the password, okay? And then you connect her computer to the router. And then she can line with her, well, sadly, boyfriend. Heartbroken aside, let's have a look at the components that we used in this scenario, okay? So, here's a question. In the scenario, what are the internet applications, all right? Just in this scenario, Line is your internet application. Okay. What is or what are Line services? The answer is video conference and instant messaging. Okay. And then what is the end system? Which component is the end system? And in this particular scenario, the end system is the laptop. Next one is what is the access network? Your entire wireless or Wi-Fi network is your access network. All right, because you is connect your the laptop, okay, through the router. That doesn't include the fiber optics, by the way. And the access link would be the Wi-Fi radio. Okay, and the most interesting question is, where do the data go after the router? Okay, so technically, after the router, you are connected to the ISP or the internet service provider. All right. Well, sometimes people try to separate the local network. Okay. Uh, Either your home network, your Wi-Fi network, your dormitory network. We call it LAN. All right, local area network. And beyond that, we call it a wide area network. All right. Well, to separate the network as in LAN or WAN, as LAN or WAN like this, it is quite easy to understand. All right. Well, it is in my building, it is in my office, it is in my room. We call it LAN. All right. And well, let me draw you a picture right here. So if you are in the inside one area that covers by one router, okay, you have a router here. Let me draw it again. Okay, you have a router here. Anything that is connected to the same router could be considered LAN. Well, because this is the area which is covered by one router. If the routers connect to another router, making a larger network, okay, like this, and here you can also have another area with the router right here. You can have another area with the uh, router right here. and these are the machines within this router. Okay, so well, people can call this LAN, and the larger side is WAN. And then if you zoom out to this router can have its own LAN, okay, and outside is WAN. It's just basically something outside of my network. Well, as you can see here, this WAN thing could be another router that connect to a larger area, like so. Therefore, if you call it LAN and WAN like this, it is a classical way to call it. All right. I don't think it will just end because your network gonna go larger and larger and larger. Imagine you're in university, right? You connect to the Wi-Fi in the classroom, okay, and that means this classroom is contained in a local area network, the classroom network, and then this classroom router connects to the building router, okay, that connects all the classroom routers together. In the if you talk about the building in the building point of view, yes, the entire building is one LAN. Okay, the smaller router inside the building is actually the subnetwork of the same LAN, and then the building router connects to the university router. That means that, well, from the building router's point of view, the entire building is his LAN, and then the WAN side is the university network. And university network connect to the ISP. University has its own LAN, and the ISP is the WAN. So as I was saying, it kind of go on and on and on. So let's just not call LAN and WAN. Just call it in the TCP terminology, basically the subnetwork. Okay. For example, in your university, you have a router. Okay. In here, you have smaller set of routers like this. Inside, you can have this smaller set of routers that connects the machine together, like so. All right. This is a subnetwork that connects to a larger network. And this too is also a subnetwork that connects to a larger network. All right. So I wouldn't call LAN or WAN anymore. As long as they connect to the internet and they use TCP/IP protocol, I would just call a subnetwork. All right. And this is basically how internet works. See, if you have a home network like so, okay, in the scenario that we had before, we have the home router, which is a Wi-Fi router, okay, that connects a laptop, okay, that connects an iPhone together. It could be via wireless, it doesn't matter. It could connect a PC to the same router. This is one subnetwork. It owns it that stand on its own. All right, and once you connect this to the ISP using fiber optics, DSL, whatever technology you're using right here, you are basically connecting your entire subnetwork into a larger one. And of course, ISP got to connect to the larger one as well. All right. Well, so all in all, LAN and WAN, if you ask me, it is kind of confusing. All right, I would just call subnetworks. But if you consult textbook or some other experts' opinion, they might say something otherwise, which is okay. All right. Anyway, just to make sure that you understand the terminology that they use, let me introduce you these words as well. LAN stands for local area network, basically your network in your local area. And as I was saying, that depends on how you define it. It could be your entire building, it could be a floor, it could be a room, it could be a house. All right. The wide area network or WAN, it is the larger ones. In classical way, LAN could be one building, and when you connect them together, this is the WAN network, wide area network that connects two buildings together, that connects two branches together, that connect two cities or two campuses together. All right. The other one is the metropolitan area network. All right, technology that connects a lot of clients in a much larger area, not just the building, not just two campuses, but it could be half or a part of the cities or the entire city. This technology, for example, WiMAX, okay, or 3G, 4G, or 5G network can be considered metropolitan area network. All right, and coming smaller, you can have personal area network, which is super small, smaller than LAN. It is a terminology that describes the technology that connects you, the user, okay, to devices around yourself. The example of such technology is Bluetooth. All right, you have well a laptop or an iPhone that connects to other smaller devices. Could be your wireless speaker, could be your it could be your printer, okay, and anything that connects devices personally. All right. Well, as a homework, all right, I would like you to also have a look what is the NFC or near field communication as well. The next topic is the network core. All right. Well, previously we discussed our own small network. All right. We connect devices, end devices to our edge router. Okay. But where else does it go? All right. It goes through a network core. Network core is a mesh of routers and switches that interconnect the internet end system together, right? Network core components and links are highlighted here in red, okay? So right here you have network edges, all right, right here, which compose of the end devices, the access link, and so on. But this router connect to other router, and connect to other routers. These networks of routers is your network core. All right. At the network core, the main question is how to transfer data through the network, or in the other words, how to move data from one end system to the other end system. All right. The routers at network cores might not look like what you have at home. Okay. It basically, you know, in the main concept is the same. All right. It try to route the data from one end to another end, from one network to another network. All right, but the scales and the speed is much larger and much faster than your home router, and it looks pretty much like this. All right, all these are the routers. All right, that's it for our first session. Okay, here is our tentative outline. All right, first we are going to introduce ourselves to computer networks. That's going to be this section, all right, and the next section. And further on, we're going to discuss layered architecture and then internet access technology, followed by the application layer protocols, all right. These few sessions here will be conducted online. I will record videos for you to watch anytime you like because some of the students are still doing internship, some are still abroad. All right. And this will cover lecture 1 to lecture 6 from the 3rd of July to the 11th of August. After that, we will meet each other in class from lecture, not 1, I'm sorry, lecture 7 to lecture 15. All right. And we will be discuss the following topics: transport layer protocols, network layer protocols, link layer protocols, and also medium access control, wireless and cellular networks. And at the end of our class, our course, we will discuss cybersecurity and data encryption. All right. Well, I am not sure when midterm exam going to take place. All right, and but I guess that the topic that should be included in the midterm exam would be around here up to the application layer protocol. Right? Okay. Now let's discuss the cost evaluation. All right. Well, most of the score would come from your exams, midterm exam and the final exam. All right, midterm exam being 40%, final exam 50%. And we also have the participation score, which accounts to 10%. How do you get this score? You can just ask any questions, answer any question, discuss anything in class. All right. And every time you do, I will give you some score. If you just answer shortly, you might get 1 point, you might get 2 points, you might get 3 points. And if your questions is interesting, that could be even larger. And that 10% would is and that 10% might not look like much, but any score you score in class, 3 points, 2 points, 1 point, okay, it accounts to 1% directly. All right, I will not divide it further. It means that you can try how many times you like in the class. You can raise your hands anytime. You can discuss anytime. All right, you can earn points quite easily without nothing to lose. In the exam, if your answer is wrong, all right, you lose some points. But in class, you don't. You can keep trying and trying until you get that 10% full. All right. And since we're gonna meet each other only uh, well after the midterm exam or a little bit early before midterm exam, therefore this participation will be counted only in the in-class session. You don't have to come to any class, you don't have to come at all, but you're gonna miss the participation score. Right? Then the textbooks. Okay, the textbook that I would like you to buy or at least to get hold of are as follows: the computer networking, a top-down approach by Kurose and Ross, all right, and computer network by Andrew Tannenbaum. These two are the classical, especially this one. They look old, all right, more than 10 years ago, but the content inside covers all the basic that we need to discuss in the class as well. And these two textbooks are quite easy to find in Thailand. All right, that's it for this session. Okay, if you like this video, please click like and subscribe. All right, and that would mean a lot to me. I mean, seriously, I still don't know how I'm gonna post this thing online, but that is something that people say on YouTube, so I do it the same thing. All right, we see each other again next session. I will post the video as soon as possible. All right, and I will put the link to the video on our Discord channel. All right, thanks a lot for joining me today. Bye.